Hi there grade 9s and welcome back to WorksheetCloud Maths. I hope you are having a super duper day so far, and I hope that you are going to find this lesson quite exciting because remember we are going into our second lesson of transformation geometry. So it's the second in the series of transformation geometry, and let's just go over again what transformation geometry actually is. So I just want to revise a bit because we started in the previous lesson with this section. And it is the movement of a shape or point, and the result of that movement is called an image. So once you've moved the shape or point across the axis or into a different spot, as we did the last time, we call the result of that an image. So where it ends up is the image. Okay, I'm sure you remember that from last time when we did translations. Right, so transformations include translations, as you know, and reflections, and that's what we're going to deal with today, is the reflections. So these are known as rigid transformations. Why? Because the shape and size of the geometric shapes don't change, or the geometric point. Okay, so last time when we did translations, you saw that the shape the shape and the size of the shape that we translated did not change. It just changed positions on the Cartesian plane. So now we're going to look at reflections, and I'm sure you know exactly what's going to happen. So remember, if you're looking in a mirror, you're looking at a reflection of yourself. So it's almost you are looking back at yourself, and that is the reflection. Well, it's the same on the Cartesian plane. But let's have a look at it and we will go through it quite slowly. Right, so let's have a look. A reflection is when a point or shape is moved across the x or y axis. So that's already different to a translation because it doesn't have to be moved across an axis. What happens is that you follow a rule to move it to a new point. Okay, and that's what we looked at last time. So that's the difference between a translation and a reflection already, is that with a reflection, it is going to be moved across either the x or the y axis. So either the x or the y coordinate stays the same, while the other coordinate changes from a negative to a positive or a positive to a negative. So if you are translating across the, if you are reflecting across the x-axis, your x coordinate will stay the same, but the y coordinate will change to a negative or positive. Okay, so let's have a look. Okay, so if you've got an original point of 5, 3, okay, those are your coordinates, reflected across the x-axis, the new point will be 5 minus 3, right? So if you were translating or reflecting across the y-axis, the new point would be minus 5 and 3. Okay, so remember a reflection is going across an axis, either the y-axis or the x-axis, and therefore one of the points will change and the other one will stay the same. In other words, one will stay exactly the same, the other one will change in effect of the negative or positive will change. But let's put this into practice and see what it actually looks like. So here we go. There is the Cartesian plane. Okay, we're going to plot point A, which is at 5, 3, which is what we used in our previous example. So we've got point A at 5, 3. Remember, 5 is the x coordinate and 3 is the y coordinate. All right? Now we're going to reflect point A across the x-axis. Remember, that's the x-axis, so we want it to reflect down here. Almost a mirror image. Well, it is a mirror image. So remember in the beginning when I said to you, when you look at yourself in the mirror, that is a reflection. This is almost like putting a mirror up along the x-axis and seeing what it will look like. All right. So if we put a mirror up, where is this going to end up? It's going to end up still in 5. The x value will still be 5, but now the y value will be minus 3. So there we have A1, and that A1 is a reflection of point A. Okay, so point A1 is at 5 minus 3. Can you see how we've reflected it across the x-axis? So the x coordinate stays the same, but the y coordinate changes from a positive to a negative. Okay, so as you can see there, what I've just explained, the x coordinate didn't change at all, because we reflected across the x-axis. So whichever axis you're reflecting across, that point in the coordinates stays the same. That coordinate stays the same. Okay, so if we reflect the point A across the y-axis, we're going to go into this quadrant here. Okay, let's have a look what happens. All right, can you see our x value changed from a positive to a negative, and the y value now stayed the same because we reflected across the y-axis. So that becomes A2, point A2. All right, it's the second reflection that we've done from point A1 or from point A. So we first went to point A1, which is across the x-axis. X value stayed the same, y value changed from a positive to a negative. Then we went across the y-axis, so our x value changed from a positive to a negative, and our y value stayed exactly the same. You can see this is in line with the x value, and that is in line with the y value. Right. Let's have another look. Okay, let's look at another one. Here we go. We've got point C, and the point C is at minus 3. So it's minus 2 on the x-axis, minus 3 on the y-axis. Right? Okay, we need to reflect point C across the x-axis. Here's the x-axis, so we are not going this way, we're going that way. If we're reflecting across the x-axis, then our x value stays the same, but the y value from a negative becomes a positive. So let's have a look. Okay, there we've got C1. What are our new coordinates? Our new coordinates are minus 2, which is the same for C, but now it is 3 instead of minus 3. So C1, the coordinates are minus 2 and 3. Can you see it's gone into where y is positive, but x remains the same. So it's on the x line. Right. So if we want to reflect a point C across the y-axis, this time we're going to come into this quadrant here. And what is going to happen, we now call it C2, where now our y value stays the same, but our x value alters. In other words, the x value changes from a minus to a positive. So point C2 is now 2 minus 3. Can you see? Your y value stayed the same because it's on the y line, but our x value became a positive because we reflected it across the y-axis. Okay, everybody keeping up? If you're not, remember, if you've got a question, please don't forget to email your question or your query to grade9@worksheetcloud.com, or otherwise go back to the beginning of the video and go through it step by step and very slowly. Okay, right, let's go on. You try this one. There's your Cartesian plane. What I want you to do is plot point F at minus 4, minus 5. Then I want you to reflect point F across the x-axis. Then I'd like you to reflect point F across the y-axis. And then I want you to give the coordinates for F1 and F2. In other words, your two new points. So pause the video, use your Cartesian plane, plot your point F, then reflect across the x-axis, then the y-axis, and then give the coordinates of your two new points. So pause the video now, and you try it out, and then when you come back, we will go over it. Right, how did you do? Okay, there's our Cartesian plane. The first thing that you had to do was plot point F at minus 4, minus 5. So let's have a look where that is. Can you see? X is minus 4, y is minus 5. So that would be point F. Okay, now the next thing you had to do was reflect F across the x-axis. Remember, this is the x-axis, so we're going to go into the second quadrant. Okay, and there we have it. We have reflected F, and it now is F1. Because it went across the x-axis, our x value stays the same, but the y value now becomes a positive. So there we have our y value there and our x value there. But you have to write that down just now. So let's see the next thing that you had to do. You have to now reflect point F across the y-axis. okay? So now this is the y-axis. We have to cross into quadrant 4. All right, remember it is a reflection, so it's basically the same distance from both axes, okay? Right, so there we have it, and that becomes F2. Can you see how your y value has stayed the same, but your x value has changed because it's changed position across the y-axis. So then you had to write down or give the coordinates for F1 and F2. F1 we looked at just now. F1 will be -4 and the y value is 5. So it's -4, 5. Remember that is because we've crossed over the x value. So our x value stays the same. There you can see the original one and our new one, or the reflection. And our y value is now different because it was -5. It has now become 5. Then for F2, our coordinates are now 4 because our x value has changed because we've crossed over the y-axis, but the y value has stayed the same. And the y value is still -5. Okay, everybody happy? Please don't forget, if you are worried about anything, concerned or don't understand something, then please send an email to grade9@worksheetcloud.com so that somebody can help you. Or like I said earlier, go back and go through step by step in the video. Okay, right, now let's try to reflect a shape. It's not that difficult. If we follow everything that we've been doing with the points, then we will see exactly that the shape works exactly the same way, and we have to reflect each point and then join up the points to create the new shape. Okay, so we've got our Cartesian plane again, and what we're going to do is we're going to plot a shape A, B, C, okay, and we are going to join that up so it becomes a triangle. So we've got triangle ABC. Let's just quickly look at the coordinates for this. So A is 2, 4, B is 2, 1, and C is 4, 2. Remember our x coordinate always comes first, but I'm sure you know that by now and you're very happy with that. Right, so what I want you now to do is we're going to reflect triangle ABC across the x-axis. So all our x values will stay the same, but the y values will go from positive to negative. So let's have a look at that. Let's do A first. You can actually start with any one, but let's just go according to the alphabet. It's easier to keep track. And let's just do A first. So if A is 2 and 4, it now becomes 2 and -4. Okay, can you see it down there with the purple dot? That becomes A1. That is our new point. So can you see how it's reflected because we've gone across the x-axis and our y has changed to the minus side. Okay, the next point, well, we will do B. B is 2, 1, so it remains 2, but it now comes down to -1. And that becomes B1. And then we've got to do C. So have a look. C is 4, 2. It's going to remain at 4, but it's going to get to -2. And there we have C1. Now, if we join the dots, it looks like it's not going to be right because we almost imagine that this side should be the shortest side, but that would be a translation, okay? Remember, we are reflecting now, so our x-axis almost becomes like a mirror. And if you were to put the mirror over here and reflect that shape into the mirror, then the shortest side will be closest to the shortest side because that's a reflection. On the other hand, if it was a translation, then the whole shape would move just like that down here. Now, remember in the beginning, we said that these are rigid transformations because the shape and size stay the same. Well, the shape and size has stayed the same, it's just reflected itself. So this shape is the same as that shape. It's also the same size. It's just that the shorter side is closest to each other because of the fact that it is a reflection. Okay, what do we have to do next? Now we have to go back to ABC and we now have to reflect it across the y-axis. This means that our y values are going to stay the same, but the x values are all going to be in the negative. So again, let's start with A. So if we 2, 4, we're going to be minus 2 and 4. Can you see the y value has stayed the same, but the x value has become a minus. So let's put that in, and there we've got A2, point A2. Then let's do B, which was 2, 1. Okay, it's going to stay on 1 for y, but it's going to be minus 2, 1 now. And there we go. We have our B2, right? And then the last one is the C value. And remember that was 4, 2. It now becomes minus 4, 2. And there is our C2. And again, we're going to join the dots so that, or join the points, so that we look at the same shape. So A to B, B to C, C back to A. And can you see again, it is a reflection. It's not a translation. If it was a translation, that side would go that way. But this is the mirror, and it's a mirror image on the other side. So you can imagine it is the opposite shape, basically. All right, does that make sense to all of you? I hope it does. But can you see, basically, this is probably easier than the translation because the rule is not being worked out. The rule is actually given to you. If you go across the x-axis, the x value stays the same. The y value, the sign in front of it changes. So if it was a negative, it becomes a positive. If it was a positive, it becomes a negative. That is with reflecting across the x value, the x-axis. If you reflect across the y-axis, once again, our y value will stay the same, but the x value, the sign in front of it, will change. Okay, so now you try. It's going to be a short try, this. So here we have our Cartesian plane again. We've got a shape D, E, F, G, and we're going to join the lines, and there you have your shape. And what I want you to do here is I want you to reflect shape D, E, F, G across the y-axis. So what I want you to do is pause the video and you try and reflect that across the y-axis. You know what should happen, okay? But I'm not going to tell you because I want you to try and remember and figure it out so that you can figure out if you've made a mistake or not. Okay, so pause the video, try and do that on your own, and when we come back, we'll go over it together. Right, let's see how you did. Okay, so we are now reflecting that, and we are going to start with point D. So point D is minus 4 and 5. We're reflecting across the y-axis, so we're coming into this quadrant here, okay? And we, as you know, the y value will stay the same, so it's on the line of the y. And the x value will change its sign. So it was a minus, it now becomes a positive. So you can see it stayed on the 5, but it's now on positive 4 instead of on negative 4. And we are now going to name that D1. Okay, and then we are going to do E. E is on minus 3, minus 5. We're going to keep it on minus 3 for y, but the minus 5 changes to a positive 5. So it's actually going to come up over here. And if we didn't know any better, we would probably think it's going to go over there. Okay, but it's not because we are reflecting. All right, so there is our E1. Our F is going to go from here, which is minus 3 minus 2. It's going to come to 3 minus 2, and we have it there, and that is F1. Right. Okay, let's do G, which is the last one, and G is on minus 2 and 4, so it should come to 2 and minus 4. So it's minus 2, minus 4, 2, 4. 2 minus 4, sorry. And there we go, and that is G1. All right, and we are going to join the points, and we're going to get a reflection of our original shape. Now you can carry on reflecting. You can then reflect F1, E1, D1, E1, F1, G1. We can reflect this shape across the x-axis, in which case it will come into this quadrant. or we can go back to our original and reflect that across the x-axis, which means that it will come into this quadrant. So basically, when we are reflecting, we are mostly moving across quadrants unless our shape is actually already across the quadrants. And then sometimes you will get an overlap. But I'm going to leave you to try and figure that out in your activity that is joined to this lesson. Please do your activity and then check on the memo to see if you are correct. And once again, if you are getting confused, watch the video again or email your query to grade9@worksheetcloud.com. Right guys, that's all we've got for today because it was quite a lot to take in. Although if you follow the structure and you follow the rules, then it will be a walk in the park. Thank you so much for watching today's lesson, and I can't wait to meet with you again to look at Transformation Geometry Lesson 3. Bye-bye for now, and keep well and keep warm.